and this is paper 2 for the question 1A. The reaction between zinc and hydrochloric acid, so easy. This is a typical acid react with metal, okay, and hydrogen gas, okay. So as you are not required to write down the physical state, then forget it, okay. Part B, so part B will be get 4 marks, okay, 4 marks for your diagram. So first, you are given that the maximum temperature change is 6.6 degrees Celsius, and you are given the temperature at the beginning. So here shows the pictures, okay. I hope you can see it clearly. Now, how can we get 4 marks? First, some of you use the wrong scale, okay, because our range is only between 23 to 31 something, okay, so only this range is needed. Don't start your picture with 0 degrees Celsius, it's nonsense, okay. Well, next, you need to mention, okay, of course, copy all the data, important, and at the temperature, or at the time 1.5 minutes, you start the reaction. That's why we do the extrapolation back to the 1.5 minutes, and you are given that the maximum temperature change is 6.6 degrees Celsius. So the highest temperature through the extrapolation should be 30 degrees Celsius, okay, like this. Then you can get 4 marks. You can see the access, data, extrapolation, okay, and the highest temperature is 30 degrees Celsius. So don't make the same mistake in your DSE examinations. Well, part C, calculate the enthalpy change between zinc and hydrochloric acid. So many of you get the correct idea, yes? Okay, number of mole of zinc, well, very good, is 2 grams over the molar mass, is 0.0306 mole. Well then, he or she stopped it. Okay, you need to calculate the number of mole of HCl is M times V. Well, this process is important because you need to find out which one is limited. Okay, from the mole ratio, we can find that zinc is limited. Okay, so the heat release will be MC delta T, MC, okay, delta T. Now, here, I need to find something, okay? First, this is mass, okay? 50 cm cube is volume, not mass. You need to times density, okay? So this is what you have learned in grade 7, okay? So don't make the same mistake, okay? And some of you include the 2 grams of zinc into your mixture. Oh, this is fine, okay? There will be small difference compared with my model answer, but this is acceptable in the marking, okay? So the enthalpy change. Okay, now please remember this one is heat release. I have mentioned release already, so that's why no need to add positive or negative side. But this is enthalpy change. You need to do so. Minus 1386 over, okay, because we only, zinc is limited, so we only carry out this amount of mole of reaction. That's why we need to divide this one, and this minus 45.3 kilojoule per mole. Okay, you are allowed to use kilojoule per mole or joule per mole, is fine, doesn't matter, okay? And this is, okay, don't forget the minus sign because this is enthalpy change of reaction, okay? Finally, the actual enthalpy change, it will be will be larger in magnitude. That means the actual one will be more exothermic. Why? Oh, the reason behind simple. First is heat loss to surrounding. Very good. Okay. The second one will be the reaction is not complete. Okay, or a better idea is the heat capacity of the apparatus is ignored. Okay, we haven't counted the amount of heat energy used by the apparatus. Okay, so I think this one will be a better answer. Okay. Now, question 2. So W will be given out. So what is W? Okay, so you can figure out. Now for this one, let's count the number of carbon. 1, 2, 3, 4. Okay, 4 only. Don't mention the fifth one. Okay, and this one is 1, 2, 3. That means compound W should get 1 carbons. Okay, 1 carbons. And if we break the molecule in this way, so the carbon here, carbon 4, should be connected with okay, like this one, because this one will be broken. So the molecule is broken in this way. Okay, then because this is given that the W is a colorless gas, so it is no point. Okay, some of you get the idea. Will it be like this? Methanoic acid? No, because methanoic acid is a liquid. Okay, it got strong hydrogen bond, so it will be liquid. So no, the only possible idea will be the CO2. Okay. The next one is write down the equation for the formation of lactic acid from this element. Okay, good. Lactic acid is, you are given that already. So many of you get the correct answer. Just write down all the elements involved and form C3H6O3 liquid like this. Okay. And because this is the formation equation, so physical state as mentioned here must be included. Okay. Well, next is try to use the data. Now, this is quite disappointed because many of you cannot see this one. This is a combustion data. Okay, combustion. So you should include your word is okay. This is our formation equation. Okay, formation equations. Then, after combustion, all of them should give out the same product. Is CO2 and H2O. Now, this one is the combustion of lactic acid. Okay, okay. And these two should be the combustion of carbon and hydrogen. Like this, okay? So this cycle, okay, will give you 2 marks, okay? And the formation of lactic acid will be first, follow the arrow here. And then reverse the direction, that means minus of the combustion of lactic acid. Like this, okay? That is, okay, 3 times and they get the answer here. Okay. next, question 3. Define the enthalpy change for the formation. Well, you get the idea. Okay, this is you can copy the definition from notes. Okay, this is the enthalpy change when, okay, now this is a keyword, 1 mole of substance is formed from its constituent element in their standard states. Okay, this one many of you have forgotten. Under standard condition, the element from their standard states. What is meant by standard state? For example, in our idea, carbon should be started from graphite but not diamond, because diamond is not standard state. Okay. Part B. Why this is not possible? Also, okay, so many of you again just give me the answer. Because side product is formed. Well, yes, but please let me know what kind of side product is formed if you use this idea. Okay, so the better idea is, first, the reaction cannot or don't start in room condition. Okay, or you may say the N2 and O2 will form NO, okay, and NO2 instead of N2O in room condition. Okay, this will be better than just give me side product will be formed. Okay. For part C, okay, so enthalpy change from formation of nitrous oxide. Okay, so here is what our target equation. Okay, from the given two. Okay, now there is only the second equation get N2O, so we have no choice. Just copy the equation 2, but in reverse way. Okay, to turn N2O from reactant to product. Okay, that's why we need a positive 193 here. Then the equation 1, okay, we got an extra carbon here, but equation 1 we got 2 carbons. So what we have done is we halve the equation 1 like this. We halve the equation 1, and that's why we halve the value. Okay, after we add 2 equations together, we can cross out the CO, we can cross out the carbon, and the result is what we want. Okay, so the equation will be like this, and the answer is 82.5 positive. Okay, don't forget the positive one, or you may lose your mark. For question 4, okay, the first one is name the above instrument that is used for measure the physical parameter. Okay, the instrument is, okay, you refer to a note is a calorimeter, and this is used to measure the light absorbance. Some of you write down the color intensity. I think it is acceptable, but if in case of the public examination, I still recommend you to use light absorbance will be better. So for part B, why the progress can be followed? Okay, now some of you just write down because there is color change, color intensity change. Okay, I know the idea is correct, but not accepted in the examination because you need to tell me what change and why. So the better answer will be because throughout the experiment or throughout the reaction, the brown color of iodine will be decolorized to form iodide, which is colorless. Okay, mention the chemical and mention the color change will be important. Okay. Part C, why the presence of catalyst can speed up the reaction. Well, you are given 2 marks for that. So first, because a catalyst can provide an other reaction path. Okay. Oops. Okay. Provide another reaction path with lower activation energy. Well, this is the first mark, okay? And the second mark is, as a result, more reactant particle will have energy equal or greater than the iteration energy. Okay, this is the second mark. Okay, this is the first mark, this is the second mark. Okay, for question 5, the initial rate. Okay, so you are given the point already, so I think this is easy for you. Okay, for the first reaction rate, okay, the initial rate will be, okay, just like calculate the slope. Okay, but don't forget the unit is 73 cm cube per minute, this time not per second. Okay, and of course there will be marks for your unit. Why tangent A is more steep than B? Because reactant is more concentrated in A than B. Okay, the concentration of reactant will be higher, okay? Because the reactant is used up during the reaction. Okay, so a little bit troublesome, but you need to mention both points. First, you need to tell me the fact that the reactant is more concentrated in A. But second point is why? Because the reactant is keep using throughout the experiment. Okay, and finally is calculate the molarity of hydrogen peroxide. So you need to first find the number of mole of oxygen. Okay, and here you can see the final one will be 84. Okay, so 84 cm cube number of mole of O2 is 84, but don't forget you need to change the cm cube into number of mole. This is the molar volume. Yes, 3.5 times 10 to the minus 3 mole. Okay, actually in the final stage we get this amount of O2, but you need to emphasize is the equation H2O2, how to become H2O and O2. You need to balance the equation like this. Okay, so the molarity of H2O2 will be double amount of the oxygen's mole. Okay, and the volume equals to okay, like this. Now for question 6, okay, the first is the equation between calcium carbonate and dilute hydrochloric acid. Well, easy. Calcium carbonate and dilute hydrochloric acid. Okay, so easy that some of you just can give me the answer without any procedure of balancing. Good. CO2 and H2O. Okay, easy for most of you. The second one is why the hydrochloric acid should be saturated with carbon dioxide. Okay, it's because to minimize the amount of CO2 dissolved in the solution, because CO2 formed will dissolve in the solution and hence reduce the amount of volume gas we obtain. So we to do something to make the CO2 not dissolve. Okay, part C, volume of gas given out. So refer to the refer to the graph first. the number of calcium carbonate is 1 gram. Number of mole of calcium carbonate is 1 gram over the molar mass. That is, well, this time is not better for us to round off, okay? And the number, okay, mole of HCl is m times v. Okay, here shows. So these two values were obtained, but we need to find out which one is in excess. So this, okay, after you calculate these two, you will get 1 mark. But from the mole ratio, this should be HCl is limited because the ratio is 1 to 2. Okay, so HCl is limited. So the amount or number of mole of CO2 formed will be depends on the number of mole of HCl. This one, okay, and hence the volume will be you can either express your answer in dm cube or cm cube. It's fine, okay, it's fine. Well, next one is the experiment is repeating. Use this amount 30 cm cube of hydrochloric acid. Now, from the value, the volume will be less, but it is more concentrated. So you should keep in mind, okay, actually the number of mole of HCl is m times v, which is greater than before, okay, greater than before. Now, at first, or in the last section, the HCl is limited, but this time, no, HCl is in excess. So, the curve should be higher, okay, not only higher, but steeper because the concentration is more, okay, so the reaction rate should be faster, okay. And part E, we repeat the reaction with this time with sulfuric acid in curve Y. Why a smaller volume will be obtained? Because, well, easy, because insoluble calcium sulfate is formed, which stops the further reaction, okay, which stops the further reaction. And finally, refer to the collision theory, suggests 2 reasons to show that the rate change in different temperature. Okay, you are requested to discuss the effect of temperature on the reaction rate. Okay, there are 2 aspects. Okay, when temperature increase, okay, the first will be the average kinetic energy of reactant increase, okay, and hence larger portion of reactant will have energy equal or greater than the activation energy. Okay, so this is the first mark, this is the second mark, and the result will be the effective collision frequency increase. Okay, and that's the end of this paper.